Welcome back once again, and today we're here to talk about the home networking design for a self-hosted environment. So, there are certain design goals for a home lab local area network. There's the role of the router, changing your default network address and address range, and subnet mask, media access control, otherwise known as MAC addresses and MAC address filters, DHCP, the DHCP scope, static addresses, and DHCP reservations, and auto configuration addresses, otherwise known as APIPA, and that is not a beer, and domain name servers. And then finally, security methods. So, what are the design goals for your LAN? Well, we want to achieve reliability and stability on a local area network. Really on any local area network, but on a local area network where you're going to do self-hosting, we really want reliability and stability. We also want security. We want to understand everything on the network and what requirements exist. There are wired nodes and there are wireless nodes, and there's performance issues. We want to understand all the devices on the network and know what they are. We want the latest updates to assure all of the above. So, what is the role of the router? The router is the traffic cop for all your traffic on your LAN and all outbound as well as inbound communication. The router is sometimes referred to as a firewall because it controls inbound and sometimes outbound access. Most importantly, the router is the gateway to the public internet. The router configuration determines your level of performance and also security. And the router provides the means for systems to communicate with each other on your LAN. It's not truly yours until you void the warranty. A friend of mine told me that one time. But seriously, too many use the router exactly with the configuration it was shipped with. And today I want to challenge you to do a little bit more with that. So be bold, learn the settings, and make changes to understand everything on your router. After all, it controls your network. So where do I start? Well, almost every retail router is sold with a default LAN address range of 192.168.1. whatever number with a 24-bit address space. Consider changing it because this will be helpful if you ever opt for a site-to-site VPN. If you do a site-to-site VPN, which is connecting two networks to each other, they have to have different address ranges to achieve that. So choose an IP address range inside the private address ranges of either the 10.0.0.0 or 172.16.0.0 or 192.168.0.0 and any subnet mask range inside of those three private address ranges is appropriate. In my particular case, my personal home network is on 172.16, but that's for my main network. I have VLANs that operate in the 192.168 range. So understand subnets. You will need them for traffic management. Okay, what about MAC addresses? That is not the address on a Macintosh computer, by the way. A MAC address is an IEEE 802 standard unique hardware address on the network interface adapter. So any piece of hardware that you have, a smart speaker, a computer, a laptop, a phone, a tablet, anything has a hardware Ethernet adapter, be it wired or wireless, and every one of those has a MAC address on it. MAC addresses are referred to also as the hardware address, and it's a 48-bit address which is divided into 6 8-bit octets. The upper three octets are what we call the vendor code. So the most significant part of it, the first part, is the vendor code. For example, my desktop Mac address starts with B88584. And that particular hardware code will tell you the vendor hardware code, the most significant part there. And in that case, it maps to, say, it's from Dell Incorporated. And sure enough, I have a Dell computer here I'm working on. So this website here, https://dnschecker.org, would let you believe that it's to go out and look at websites or look at DNS sites. And it's not really. It's a website that lets you enter either the 3 upper octets of a MAC address and it will return a vendor code, or it lets you type in a vendor and it will return the various MAC address vendor codes associated with that vendor. And that's real handy. This is really useful if you're looking out on your network and you want to define nodes on your network that your router sees, but you don't know what they are. So for ultimate security, most routers will allow you to filter authorized network clients by known MAC addresses. Companies use this often, particularly in data centers. Sometimes they lock down ports on a switch to only communicate with a given MAC address so that nobody can walk into a data center and just plug something into a switch and get it to work. So with the advent of virtual machines and containers, things like Docker and LXD, MAC addresses may not map back to a vendor hardware code. So in some of my previous vendors, we talk about containers, and containers are virtual. And they can arbitrarily take on any MAC address. And although it's a MAC address that you can layer TCP/IP on top of, it may not tie back to a particular vendor code specifically because it's virtual. It's not a real piece of hardware. So MAC addresses are important because they're the basis for managing TCP/IP on the network. You have a piece of hardware or virtual device, it has a MAC address. The MAC address is going to get assigned a TCP/IP address. So how does that happen? It happens through DHCP. Once you determine your network subnet, for example, 192.168.50.1 with a subnet mask of 24, you need to establish a DHCP scope. So DHCP is called Dynamic Host Configuration Protocol. It is the protocol by which computers on your network can obtain a MAC address, or a TCP/IP address. So this is an example from my router, and as it turns out, the 192.168.50 network happens to be a VLAN on my network. And so you can see here that the gateway IP is 192.168.50.1. That means it's the address of my router. It's how you get off the 50 network and get to other networks or get to the internet. The broadcast ID is always that network ID, 192.168.50, ending in 255, because the way that TCP/IP version 4 communicates is through broadcasts. And then the network IP node count, in this case, with that subnet mask of /24, gives me 254 nodes. And so therefore the range is from 50.1 to 50.254, and the subnet mask being /24 means 255.255.255.0. So in this particular case, this VLAN is running a DHCP server, and I arbitrarily set the DHCP range from 50.6 to 50.254. So that means that, well, .1's already taken up by the gateway address, the router. So that means that .2, .3, .4, and .5 can be used for static addresses. And the rest of the address range is used for DHCP. And then down here at the bottom, I have a manual setting for my DNS name servers, which we'll get to here in a bit. So DHCP scope size. The scope size should be manageable and according to what you need. As an example, of 50.1/24 might have a scope of, in my last page you saw, from 6 on up to 254. Here I give an example from 10 up to 254. If it's from 10 to 254, that means the static addresses could potentially be numbers less than 10. So DHCP usually sets aside a few addresses outside the scope for static addressing. That's what we've been talking about here. Do not static address inside the DHCP scope. That means don't set up a new computer, don't set up a virtual machine, don't set up a container to use an address inside of your DHCP scope. The reason for that is because if you do that, there's no way the DHCP server can determine that the address is used. So we'll show a way around that here shortly, which is what I call a preferred best practice. So consider using what are called DHCP address reservations instead of static addressing. And this moves all address management to the DHCP server and is easier to manage. So rather than setting up a new machine and saying, well, I don't really want this thing to have a dynamic address, I want it to have the same address all the time, instead of going into the operating system and statically addressing that thing at, say, .100, instead, go into your router, locate the system when it comes up at whatever address, tag that system, change it at the router end to whatever address, and then say that you want to keep that address. The different routers have different way to do it, but that's what's called a DHCP address reservation. So it's effectively the same as a static address. The only difference is it's managed at the router, and that's what I consider a best practice. So DHCP tracks systems by MAC addresses. That's how you know when a machine comes online and it comes back up and you say, well, I have a DHCP address reservation for this computer at 192.168.50.100. Well, how the heck does it know when it boots up next time to be at 100? Because it has a particular hardware address and it gets that address every time. And that's how DHCP tracks which TCP IP address should be assigned to which machine. It does it by MAC address. So that being said, it's very important to back up your router configuration. If you have a managed router, it does these types of things to prevent losing those DHCP reservation information by MAC address, because that's an important part of your database. It's an important part of your configuration and something really needed in a self-hosted environment, especially if you have lots of VMs or lots of containers. So what if my DHCP server's offline? So this is possible. I mean, I usually recommend that your DHCP server be a subfunction of your router, but there's nothing that says it has to be. Your DHCP server could be another server in your network. Well, what if it's down and something can't get a DHCP address and the client's set to DHCP? Well, DHCP servers are the thing that grant the address to clients on the LAN automatically. If the server's not up and the client wants a DHCP address, does the client just die? And the answer is no. So a Windows-based computer, and actually I believe Linux now also, but I can tell you for sure that Linux-based computers configured to use DHCP, if they don't find a DHCP server, they can automatically assign themselves an IP address even if a DHCP server is not available. This is sometimes called the auto configuration address. So the Internet Assigned Numbers Authority, the people that put together who gets what addresses on the internet, came up with those private addresses that are non-routable for your private network behind the NAT. Things like the 10.0.0.0 addresses, things like the 172.16.0.0 and the 192.168.0.0. Well, they've also reserved, IANA has also reserved 169.254.0.0 all the way to 169.254.255.255 for auto configuration IP addresses, otherwise known as automatic private IP addressing. So if your DHCP server is offline, it will use the auto configuration ID and it will snatch an address in the 169.254 network. So APIPA, as it's called, and again, that's not a special beer, it's not an IPA, don't get all excited, provides an address that's guaranteed not to conflict with routable addresses, because this is, again, one of the non-routable addresses. So if you see your computer is using a 169 address, look into why your DHCP server is not reachable. My strong advice is don't use APIPA as a long-term solution. The auto configuration address is just kind of a way of getting you on the network as a temporary workaround, but don't use it as a production thing. So the next subject we want to talk about is domain name service, DNS. DNS is the phone book of the internet. It's a means to translate a domain name to an IP address. Each LAN defined on your router has a definition for the DNS servers to be used, and each VLAN has its own DNS servers that it can point to. They can be different if needed if you have a VLAN configuration. So DHCP, as part of what it does, it just doesn't assign an IP address to the client requesting an address, but it also can assign a primary and secondary DNS server to look up its names on. So consider using a more privacy-centric DNS like Cloudflare. And this is a really good commercial here to point out, by the way. So by default, your ISP will just provide its own DNS servers. And if you don't do anything on your network, you're using their DNS servers. And recently, a lot of people have been going, well, I need to go out and use Google because they're faster at 8.8.8.8. So, here's the thing about being privacy-centric. Well, what's Google's biggest business? And the answer is selling data. So there's a little bit more privacy-centric DNS service, and it's Cloudflare. For IP4, IP version 4, their primary DNS server is 1.1.1.1, and their secondary is 1.0.0.1. Hey, little tech tip. There you go. I'll get that right. Use 1.0.0.1 as the primary and 1.1.1.1 as the secondary. And for IPv6, they use these two addresses. So if you have an IPv6 network, it also needs the designation of DNS servers. So those are the ones you would use. Oh yeah, so DNS is local also. Your DNS, your local network can also run a local DNS resolver. So the Linux DNS server is a program called DNS Mask, DNS-MASQ. A program called Pi-hole, which you see a lot of documentation, a lot of videos on the web, is a self-hosted application that actually uses DNS Mask to provide DNS forwarding, local DNS, and also the main reason why people use it is because it provides adware and malicious site blocking. Because essentially it sits between you and the DNS server, so that's able to block a lot of ads and block malicious sites. So a local Pi-hole can also provide local DNS on your LAN. So if you prefer not to refer to that node as 192.168.50.100, you can give it a name on your local LAN and then refer to it as a name. And Pi-hole is capable of doing that. The later versions of it are. And your DHCP server can provide the local address of your Pi-hole as the primary DNS server. And then what happens is instead of, say, sticking 1.1.1.1 in your DHCP server configuration, you stick the address of your Pi-hole in there, and then it goes through the Pi-hole before it goes out to your upstream, maybe Cloudflare DNS. So there's another product or another program in Linux called Unbound, and it is a validating recursive caching DNS resolver that can enforce DNS over TLS lookups. So everybody thinks that your data is secure over SSL, and that's true because SSL encrypts everything. But the one thing it doesn't encrypt is it doesn't encrypt the DNS names. That's how your internet service provider knows all the sites you're going to. Well, there's a protocol. It just isn't in much use right now. A lot of browsers support it, called DNS over TLS, and basically it encrypts your DNS lookups also. And so Unbound will encrypt DNS over TLS on your entire network. Unbound can reference the top level domain, what's called the TLD, and bypass all commercial DNS by operating as your own personal authoritative DNS resolver. And if you don't know what that is, look up authoritative DNS and you'll see some good information about that. It's all about security and privacy, right? So security methods. Routers are firewalls. They protect and allow inbound access for both port forwarding and routing rules. An intrusion prevention system, IPS, is a network security threat prevention technology that examines traffic patterns through deep packet inspection. IPS can selectively block particular traffic types with the use of routing rules that look at DPI traffic. Example, you could go out and say, I want to block all peer-to-peer traffic, or I want to block all torrent traffic on my network. And it would block that outbound traffic from you using those particular applications. So routers that support both deep packet inspection and IPS have those capabilities. So DPI can used to monitor or disallow outbound suspicious traffic, thus reducing the risk of Trojan software operating inside the network. So everybody's always trying to say, well, my router's a firewall and it protects me. And what they really mean is it protects you from inbound threats. But how do you know everything inside your network is safe? How do you know that that new security camera you just put in doesn't have some kind of a Trojan built into it? So if you've got your router monitoring this traffic, you can take care of that. So IPS and DPI together, their scanning can block or allow traffic as required. Also, a lot of routers support what's called geo-blocking, where you can block particular access by IP address. And that means that IP addresses from maybe a certain part of the world are not allowed to be reached from your system, or people in certain part of the world are not allowed to reach your system, depending upon that. At various times, when the geo threat from a particular part of the world mounts up, I might disallow that country for a while. So virtual LANs, otherwise known as VLANs, are separate address ranges where traffic can be isolated for security and performance. VLANs are just about like magic because they allow multiple networks and multiple address ranges to run on the same cable. I have some other information about that in my other videos. Honeypots are faux servers, basically false type simulated servers that sit on your router. And the router can establish a honeypot to attract cyber attacks because they appear as security vulnerabilities. Routers that support honeypots are good for assessing vulnerabilities and determining current attack risks. So, keep your LAN up to date. Keep your router updated to the latest firmware. If there's no new firmware, hey, replace the router. If you look at your router and your router vendor has not come up with new firmware for that model for a year or 2 years, that router is out of date. Replace it, especially if you're going to self-host. Track and monitor all of your LAN nodes. You should know what's on your network. Watch for new MAC addresses and new IP addresses showing up that you don't understand. So, in summary, actively design your LAN. Don't let it default to factory router standards. Just because it comes that way out of the box, go make changes. I mean, the obvious thing that people say is, hey, always change the default password on the router. Well, it's way beyond that, guys. Turn on security like intrusion prevention system. It's really powerful capability. If your router lacks IPS, replace it. Buy another one that does. Understand and name everything on your local LAN. Use DHCP Address Reservations because it's the best way to manage your addresses in use on your network. And consider using Pi-hole and Unbound to increase your privacy. And consider using VLANs to isolate traffic for security and performance. And remember, self-hosting demands a more secure network than just a default network that you might have. Anyway, thanks for visiting with me today. And if you got to this point, please subscribe and like, and we'll see you next time on Down the Road. Thank you.